So we have g of x being equal to x to the fourth minus x to the fifth. And what we want to do, without having to graph g, we want to figure out at what x values does g have a relative maximum. And just to remind us what's going on at a relative maximum, so let me draw a hypothetical function right over here. So a relative maximum is going to happen, so you can visually inspect this. Okay, that looks like a relative maximum. It's kind of top of a mountain or top of a hill. These all look like relative maxima. And what's in common? Well, the graph, the function, is going from increasing to decreasing at each of those points. It's going from increasing to decreasing to decreasing at either of the points. Or you could say that the first derivative is going from positive to negative. So if you look at this interval right over here, g prime is greater than 0. And then over the next interval, when you're decreasing, g prime would be less than 0. So what we really need to think about is when does g prime, so let me see, relative, we care about relative maximum point. And so that's essentially asking, when does g prime go from positive to negative? I wrote from g prime greater than 0 to g prime less than 0. And the values that we could look at, or the points, are our critical points. And critical points are where g prime is either 0 or it is undefined. So let's think about it. Where is g prime of x equal to 0? G prime of x is equal to 0 when, let's just take g prime of x. You leverage the power rule right here. 4x to the third power, 4x to the third minus 5x to the fourth minus 5x to the fourth is equal to 0. Let's see, we can factor out an x to the third. So we have x to the third times 4 minus 5x is equal to 0. So this is going to happen when x is equal to 0. That I could, let me not skip steps. So this is going to happen when x to the third is equal to 0, or 4 minus 5x is equal to 0. For x to the third equaling 0, well, that's only going to happen when x is equal to 0. And 4 minus 5x equaling 0, we'll add 5x to both sides. You get 4 is equal to 5x. Divide both sides by 5. You get 4/5 is equal to x. So here, these are the two places where our derivative is equal to 0. Now, are there any places where our derivative is undefined? Well, our function right over here is just a straight up polynomial. Our derivative is another polynomial. It is defined for all real numbers. So these are our critical points, or we could even say critical values. Now let's think about what g prime is doing on either side of these critical values. And I'll draw a little number line here to help us visualize this. And so there we go, a little bit of a number line. And let's see, we care about 0 and we care about 4/5. So let's say this is -1, this is 0, this is 1. And so we have one critical point at, let me do this in magenta. We have one critical point here at x equals 0. And then we have another critical point. I will do this at x equals 4/5. So 4/5 is right around there. So that is 4/5. And let's just think about what g prime is doing in these intervals. And these critical points are the only places where g prime might switch signs. So let's first think about this. Let me pick some colors I haven't used yet. So let's think about the interval from -infinity to 0. So this is the open interval from -infinity to 0. And we could just plug in a value. Let's try -1. -1 is pretty straightforward to evaluate. So let's see, you have 4. You're going to have 4 times -1 to the third power. So that's going to be 4 times -1 minus 5 times -1 to the fourth power. So that's just going to be 1. So let's see, this is going to be -4 minus 5, which is -9. So right over here, g prime is equal to -9. And so we know over this whole interval, since it's to the left of this critical point, we know that g prime of x is less than 0. And so our function itself is decreasing over this interval. And so we know we need to go from increasing to decreasing. So you can already say, well, we can't go from increasing to decreasing at this critical point because we're already decreasing to the left of it. But anyway, let's just think about what's happening in the other intervals. So in the interval between 0 and 4/5, so that interval right over there, so it's between 0 and 4/5. Well, let's just sample a number there. Let's say the number, I don't know, 1/2 might be really straightforward. So we can evaluate g prime of 1/2. G prime of 1/2 is equal to 4 times 1/2 to the third power. 1/2 to the third power is 1/8. So it's 4/8, or it's just 1/2 minus 5 times 1/2 to the fourth. So that's 5/16 minus 5/16. And so this is equal to 8/16 minus 5/16, which is equal to 3/16. But the important thing is it's equal to a positive value. So in this blue interval right over there, and actually let me put 4/5 in a different color so we see that it's not part of that interval. So in this light blue interval right here between 0 and 4/5, g prime of x is greater than 0. So we know our function is increasing. And so let's see what's happening to the right of this. And the easiest value to try out would just be 1. So let's try out x equals 1. It's in that interval. So when x equals 1, I'll just write g prime of 1 is equal to 4 minus 5. 4 minus 5, which is equal to -1. So g prime of x is less than 0. G prime of x is less than 0. So our function, so we could say g is increasing here. It is decreasing. Oh, sorry, let me be careful. G is decreasing here. The function itself is decreasing because our derivative is negative. Then our function is increasing here because our derivative is positive. And then our function is decreasing here. So at what critical point are we going from increasing to decreasing? Well, we're doing that at x equals 4/5. So we have a relative maximum at x equals 4/5. If they said, well, where do we have a relative minimum point? Well, that's going to happen at x equals 0. We're going from decreasing to increasing. But we've answered their question of where do we find a relative maximum point.